Okay, now we're going to be doing some gas stoichiometry at non-standard temperature and pressure. Okay, so this is going to involve using a lot of the skills that we have been building. So you need to have a very firm grasp on how to use the ideal gas law, which is the Pivnert equation. That was the very last thing that we did in this class. But you also have to remember how to do stoichiometry. So if you do not remember how to do that, go back in the lessons and go through and review stoichiometry. Okay, go back in your notes and review how to do that. That's where we are converting between all kinds of different items. So we have a chemical equation, and remember that the key step in stoichiometry is that mole to mole ratio using the balanced equation. Okay, if what I just said does not sound familiar at all to you, go back to the stoichiometry lesson, review it, get a good grasp on stoichiometry before moving forwards. Okay. So with gas stoichiometry, remember that the constant we're going to use to help us convert between moles and liters of the gas is 22.4 liters per mole. Okay, we learned that number back when we learned about stoichiometry. Okay, but now we're going to be doing this at non-standard temperature and pressure. Everything we did before when we used stoichiometry and gases, we did at standard temperature and pressure. But now we're going deeper. We're digging deeper into the behavior of these gases. So how are we going to do gas stoichiometry? Well, it's going to depend on what we're given in the problem. If in the problem we are given the volume of the gas, we are given liters, then our first step is to use the ideal gas law, and the second step will be to use stoichiometry. However, if we are looking for the liters of a gas, so the question says, what is the volume? Then we're going to do the reverse. Then step 1 is going to be to do stoichiometry, and step 2 is going to be using the ideal gas law. Okay, so let's look at a couple of example problems. I'm going to do 2 problems for you. One starting with liters and one looking for liters, so you can see how these work. Okay. All right. So what volume of carbon dioxide forms from 5.25 grams of calcium carbonate at 103 kilopascals and 25 degrees Celsius? Okay, lots of information in this problem. Okay. So, but it does say what volume. Okay, so we are looking for the volume. So we are going to start with stoichiometry, then do the ideal gas law. Okay, so first we need a balanced equation. So pulling in that lesson that we learned about equations, how the equations are going to be written, how we balance those equations, everything coming together throughout the semester now. Okay, so our balanced equation, okay, CaCO3 creates CaO and CO2. Okay, so there's my balanced equation. 1 C on this side of the arrow, 1 Ca on this side of the arrow, 1 carbon, 3 oxygens, 1 here, 2 here, balanced. Okay. And I'm given 5.25 grams of the calcium carbonate, and I want to know what volume of carbon dioxide forms, so how much of the CO2. Okay, so using stoichiometry, start with what we know, 5.25 grams of the calcium carbonate. Okay, now I need to get this into moles, so how do I go from grams to moles? I use my molar mass, which is 100.09. Where did that number come from? Okay, this number comes from your molar mass using your periodic table. So you do calcium plus carbon plus 3 times oxygens and add those all together to get that 100.09. So that came from my molar mass and using my periodic table to add them all together. Okay, and my molar mass is grams per 1 mole. So the 1 mole goes on top. That way my grams can cancel off. Okay, now I'm ready for my key stoichiometry step, the mole-to-mole ratio. Where do I get that mole-to-mole ratio? That's where I need the balanced equation. Okay, so remember for my mole-to-mole step, it's the number that comes in front, the coefficient. So I have mole of CaCO3 on top. I need mole of CaCO3 on the bottom. There's a coefficient. There's no coefficient, which means it's an understood 1. And I'm trying to get to my unknown, the carbon dioxide. That also doesn't have a coefficient, meaning it's an understood 1. Okay, my moles of calcium carbonate cancel, and I'm left with moles of CO2, which is what I want. So then I multiply the numbers on the top, divide by the numbers on the bottom, and I get this number in my calculator, 0.0524. Now I'm not going to round yet. I'm not worried about sig figs yet. Remember, we want to keep numbers until we get to the very end, then we round for those sig figs. So I'm going to keep my whole number there. Okay, now that I have my moles, now I can put this into the Pivnert equation, that ideal gas law equation. But I'm out of space on this slide, so we're going to move it to a new one so we can do our math for that. Okay? Okay, so what do I know that's going to go into that ideal gas law? I know my pressure, that's provided in the problem. My volume is what I'm looking for. My moles, that's what I just calculated using stoichiometry, so I brought that from the last slide. Okay, I've got my temperature, but it was given in Celsius. Okay, it was 25 degrees Celsius, so immediately convert that into Kelvin because we always use Kelvin. So just add 273 to it because that's my conversion. And then for R, I got to look at which one of those constants. Okay, so I'm going to look on my little cheat sheet that I got. I see that I'm given kilopascals. So I am going to use the one that has kilopascals. Okay, and then just plug these numbers into our equation. Okay, and solve. So to solve, the first thing I'm going to do is multiply these three numbers together. Okay, and then divide by 103. Okay. If you're paying attention to your units, you'll see that when you multiply these three numbers together, your moles and your Kelvin cancel off. And then when you divide by kilopascals, the kilopascals cancels off, and you are left with decimeters cubed. So your volume answer is in decimeters cubed, which is 1.3. Okay, so plug that into your calculator. Make sure you get this answer. If not, get into contact with me. And now is where I rounded to get my correct sig figs. 25 degrees only has 2 sig figs, so my answer only has 2 sig figs. Okay? All right, now let's do a problem where we work in the other direction. Right? How many grams of aluminum 3 oxide are formed from 15 liters of oxygen at 97.3 kilopascals and 21 degrees Celsius? Okay, so this time I am given a volume, I'm given liters, I'm asked to do grams. So since I am given liters, I'm going to start with the ideal gas law first to calculate my moles, then I will use my moles to do stoichiometry to calculate grams. Okay, so I'm given liters, so going to start right off with that ideal gas law. Okay, so what am I given? I'm given a pressure, 97.3, right here. I'm given a volume, 15 liters. My N is moles. I don't know that yet. I've got to calculate it. My temperature is 21 degrees Celsius, so we've got to convert that into Kelvin by adding 273. And then which one of my R's am I going to use? In the problem, I'm given kilopascals, so I've got to use the number that comes with kilopascals, which is 8.315. Okay. All right, going to plug these right into the problem. Okay. Luckily, liters and decimeters cubed are a direct conversion. With gases, liters and decimeter cubed are equal. So even though I was given liters, that is the same as decimeters cubed. Okay, so we can write decimeters cubed in our problem. And just like before, we're solving for n, so the steps are a little bit different. So first you multiply these two numbers together. Then you multiply these two numbers together. And then to get n, you will need to take the answer here divided by the answer here. Okay, so just doing that algebra. If you need to see that step worked out, get into contact with me. I'll be happy to work through the problem with you step by step so you can see those worked out. Okay? So your answer you should get here for your moles is 0.597. Okay, we're not rounding yet for our sig figs because we're not done, right? This is only step 1. We found our moles. Okay? And if you cancel off your units, you will be left with moles. Okay, now that we have moles, now we need to do stoichiometry to go from moles to grams. But again, I'm out of room on this slide, so let's do that bit of math on my next slide. Okay, all right, so this number I just put in, that's what I got from doing PivNert, doing that gas law. That's the number we just calculated. So we have 0.597 moles of O2. But we want to know how many grams of aluminum 3 oxide. Okay, so I need a balanced equation. So I wrote out my balanced equation. And I already have moles. So now I'm ready for that key stoichiometry step, the mole to mole ratio. Okay, so I have 3 moles of O2. Where did that 3 come from? That came from my balanced equation. Okay, looking at this coefficient, it takes 3 oxygen molecules to make 2 aluminum 3 oxides. Okay, so 3 oxygens to 2 moles of aluminum oxide. Okay, so that's where that 3 and that 2 came from. It came from that balanced equation right there. Okay. Now I have my moles of O2 cancel off. I'm left with moles of Al2O3, but I need grams of Al2O3. How do I convert from moles to grams? I use my molar mass and my periodic table. Okay, so 1 mole, that goes on the bottom. That way those can cancel off. Where did this number come from? By adding together from my periodic table 2 aluminums plus 3 oxygens gave me 101.96. That's where that number came from. Okay, then I'm going to multiply the numbers across the top, divide by the numbers on the bottom, and I get 41 grams. Why 41? Because 21 degrees Celsius only has 2 sig figs, so my answer should only have 2 sig figs. Okay? All right, this is hard, right? This is a lot. We're putting a lot of stuff together. We're writing equations. We're balancing equations. We're doing stoichiometry, and we're doing ideal gas law. A lot of stuff coming together. So if you are totally lost and you have no idea what's going on, get into contact with me. Let me help you. If you are getting stuck on one of those parts, get into contact with me. Let me help you. Okay? Remember, you still have your notes. You still have access to those learning materials. You can always go back, re-watch the video on balancing equations, re-watch the video on stoichiometry, whatever you need. But if you need me, let me know so I can help you, because it's time to do some independent practice.